Hi everybody, this is Miss Anderson here, just coming to you right off the slopes. I'm supposed to meet Mrs. Von Eschen here for Lab 19, which is all about seasons, but I can't find her. Let me just look around a little bit. Oh, by the way, science rules. Let's see what I can find. She is so busted. Look at her out there, just enjoying the sun. She must think it's summertime. I gotta get her. Hey, Mrs. Von Eschen.
Yeah.
What are you doing out there?
Oh, I'm just, absorbing a little ultraviolet radiation from the EM spectrum.
Oh yeah, that's pretty high energy stuff, isn't it?
Yeah, you got that. Sure feels good.
Well, I'm glad you're really relaxed, but we're supposed to be doing a lab together on seasons.
Right.
Can you join me?
Yep, I'm ready.
Okay.
Yeah, did you just get back from skiing?
I did, yeah. It was a beautiful day out there on the slopes. So,
Awesome.
yeah.
Wow, what a great day to be studying seasons.
I agree. Aren't we lucky?
We are. Hi, everyone. We're going to continue working on Lab 19. Now, you've already made your hypothesis, these three different parts. And the part that we're going to focus on is the third step in the hypothesis. So if you look at the area that you shaded, it's going to be between two letters. And each of these letters, A, B, C, and D, represent a starting position for each of the four seasons that we have in Minnesota. Now, if you look at our setup here, we have four globes around the room, and they have a letter on top of them that tells us which position that represents. So we're going to do a lab that collects some data to see if we can figure out which of those four quadrants represents summer. So keep in the back of your mind at all times what your prediction is. Did you predict it's from A to B, that represents summer, or B to C, and so on, all right? Now, we also have the sun in the center of this setup, and the sun will be represented by a very intense light bulb. It's a 200-watt light bulb. So that's our sun. We've got the four different globes set up. And we also have on each of the globes some equipment. And that equipment is going to help us collect the data. So one of the pieces that you'll see is called a solar cell. All right, and the solar cell is something that will collect the light energy from the light bulb or our sun. And then we've connected it to some wires that will also be connected to this, it's called a digital meter. And the digital meter will give us a number, a piece of data that will tell us how much energy is absorbed where in the position where that solar cell is at. The units that are used on the digital meter is called a milliamp. That's not important for you to remember. I just want you to understand that there are units for measuring energy that we're using consistently in today's lab. Now, the other thing that you should be aware of, if you look at page 6, is that we know that Earth's orbit around the sun is elliptical. And that means that it's not going to be the same distance at any point in time for the start of each of these seasons. And so we set up our scale model based on these actual distances. So if we look at position A, where the sun is 150 million miles away from the Earth, our scale model that we'll be using is the equivalent of 1 centimeter equals 1 million kilometers, or 150 centimeters, all right? And then at 147 million miles away, the distance that we measured at globe B is 147, at C 149, and 153 for point D, globe D. The reason that we want you to know that is so that you understand that it's not just haphazardly put together, that we actually measured the distances of each of the globes from the sun, represented by that lamp, so that we're being accurate and true to the elliptical orbit of Earth around the sun as well. Now we're going to take a moment and pause our video to set up the lamp and get the lights adjusted. And then we'll come back and on page 6 record the light intensity at each of the globe positions to complete your data table.
Okay, everybody, now that we've got our really bright sun on and our solar cells are starting to absorb that sun's energy and give us numbers on our digital meter, we're ready to collect the data. But one thing, a really important detail I want you to notice is that all of our globes are tilted the same direction. And that's because Earth is tilted on its axis, as you've learned, but it doesn't wobble back and forth on its axis. So when we set up our Earths to mimic the actual Earth in space around the sun or in orbit around the sun, Earth is always tilted the same direction. So that's an important detail to note. And we'll be drawing that a little bit later in the lab on your paper, okay? All right, now we're ready to take a closer look at our data with the light intensity. So at position A on your paper, which is at a distance of 150 million kilometers, the light intensity falling on this solar panel, this solar cell, is 2.5. And I want you to notice this detail as well. These solar cells are taped right over Minnesota. So at our latitude in the northern hemisphere, this is mimicking what we are receiving when Earth is at position A, okay? So for letter A, please record 2.5. 2.5 milliamps.
Whoops, I got in the way. That's
Oh,
why
Mrs. Von Eschen, you caused a shadow.
I blocked the sun.
That's really interesting to note. That was a happy accident, right?
Now, that is happy. It's upside down. Let me get over here. Sorry about that, everybody. There we go.
All
It's
right.
just a little awkward working around this. Okay, 2.5.
2.5.
All right.
Now, Mrs. Von Eschen, please revolve over to position B.
Should I rotate also?
Oh, you should rotate, yes.
That might make my students dizzy, I think.
Yeah. Okay, position B, everyone. Please record the number 1.8. It's going between 0.8 and 0.9. Let's say 1.8. 1.8 is the number. All right, please continue in your revolution, Mrs. Von Eschen, to position C. Position C says 2.4 milliamps. All right, and then our last position in the orbit is position D, and this one is jumping back and forth a little bit. Looks like 3.6, everybody. Position D is 3.6. Okay, so let me just show you this on the paper. Here are the 4 numbers you should have recorded. And it's interesting to note, do you see a little pattern at all, you guys?
Yeah, there is.
I see some similarities between A and C. And then I notice a big difference between position B and position D. I wonder if that can give us any clues. More on that in a little bit.